So, here's your review for Chapter 6, Foundations of Math and PreCalculus 10. And what I want to go over is just some of the basic, most important things that you're going to have to know for your test tomorrow. All right? So, in 6.1 and 6.2, we talked a lot about slope. Okay? Slope is the measure of steepness of a line. And steepness is sort of a relative, almost made-up term that we talked about. But if something is really steep, it has a very high, a large value for slope. If something is really steep in this direction, it also has a high value, but it's a large negative value. So this one might be negative 10 for a slope. This one might be, positive 7. Okay, let's just say. And so if something is very flat, including a horizontal line, that's a slope of 0. So you have to understand that. Positive here, negative here, and 0 horizontal. And the slope of a vertical line is what? Remember that one? It's undefined, right? Or infinity, right? It's undefined slope. So you can say not defined for a vertical line. Okay, the other thing we talked about was parallel lines, right? And parallel lines have slopes that are what? If this is the slope of a given line, the slope of a line parallel is the same. It's equal. It's identical. Okay? That's very important. So if you have two lines, the definition of parallel lines would be two lines that never intersect. So they're like train tracks. They're always the same distance apart. Always. And that means that on a coordinate plane, they would have the exact same slope. All right, so lines that are perpendicular, so to this line right here, negative 5 over 4, the perpendicular line forms a 90-degree angle at the intersection, is always the opposite sign. If one's positive, the other's negative. That's the first thing. And then if it's a fraction, or even if it's a whole number, what you do is you flip the top, the numerator, and the denominator. So it's the negative reciprocal. That's what we call that. Slopes of perpendicular lines are negative reciprocals of each other. Questions on that so far? No? No question? Okay. Just trying to get your shirt off. I understand. Okay. All right. And so the other thing here too, if we're given 2 points and we don't see a graph at all, if we're just given 2 points, we can calculate the slope by taking the difference between the y values, and again you have to pick one point to be the second point, and so we take that y value of the second point and we subtract the y value of the first. We put that number on the numerator here on top. Then we divide by the difference between the difference in the x values, okay? And we put that on the bottom. And so that's how you calculate the slopes of lines, all right? A real quick example, if we have the point 1, 0 and the point 4, 7, okay? A quick drawing would be this, maybe, and this, right? So are we going to have a positive or negative slope? Positive, okay. That's what we should expect. So let's just see. The change in y, that's another way we wrote that, is the same as y2 minus y1 over x2 minus x1. Doesn't matter which is 1 and which is 2, as long as you start with the same one every time. So 7 minus 0 is going to go on top. 4 minus 1 is going to go on the bottom. So this slope is going to be 7 over 3. It's positive, and there you go. That's how you calculate the slope. Questions? So that's 6.1 and 6.2. If you understand all that, you're in good shape, okay, for early on in the chapter. Let's move on to 6.4 and 6.5. We talked about equations of lines. And so the slope-intercept form is the equation of a line, and that looks like this. Y equals mx plus b. It's called the slope-intercept form because the m is the slope. Whatever number is attached to the x, when y is all by itself and positive, is the slope. Whether it's positive, negative, fraction, whatever. So over here, if this is in slope y-intercept form, which it appears to be because the y is all by itself and positive, what's the slope here? Shout it out. Yeah, it says right there, but you see from the diagram, or from the equation, it's the number that is multiplied by the x. It's negative 5 over 4. The y-intercept is whatever constant here is in the equation. So this is plus 3. So that means that we have 1, 2, 3. We have a point at y equals 3, 0, 3. That's the coordinate. And then negative 5 over 4 is the slope. So we would go from here, if we were to sketch this, 1, 2, 3, 4, 5, down here to negative 2. and then over 4. So down 5 to the right 4. 1, 2, 3, 4. Put another point. Connect those two, and there you go, you have your line. All right? So that's how to look at the form of a line, how to get information from it, and a little bit on how to sketch that. Start with the y-intercept. In 6.5, we took a look at point-slope form, or the book says slope-point form. Doesn't matter, point-slope form. And this is point-slope form here. It is a bit of a derivative from the slope equation. If you notice, it's very similar, except here, y and x remain as y and x. We don't substitute values there. We substitute values for a single point into the equation right here. So the x value, y value. And m is the slope as well. Okay, so point, here's your point, slope form. So a line with a slope of 4 over 5 and a point of negative 2, 4, right here, would look like this. The slope would go right here in the equation. That's where the m is, right here. And the point, the x value, would go here. Notice it's x minus the x value. And the y value would go right here. Once that's simplified, and again, simplify, we'll just get rid of some brackets here like this. We'll deal with this. That becomes y minus 4 equals 4/5 times x plus 2. And that's your point slope equation. From there, you can easily see the slope and a point. Questions on this one? We can convert from one to the other pretty easily. Well, from this one to this one is pretty easy. From this one back to this one, maybe not as easy. And I wouldn't expect you to do that. We're not doing that in this course. But certainly, you should be able to go from this form to the other. And I'll do a quick example there as well. Maybe we'll do this in a different color, in black maybe. So let's do this. Y minus 4. Let's do this same one. 4/5 x plus 2. So what we do first is we distribute the slope to get rid of those brackets, and we gather like terms and isolate for y. So we have y minus 4. This is 4/5 x plus 8 over 5. That's 4 over 5 minus, or times 2 over 1. Okay? So we go y equals 4/5 x plus 8 over 5 plus 4. So we add 4 to both sides, right? Now when we want to add fractions, what do we have to do? Get a what? Yes, very good. You have to get a common denominator. So 4 over 1 is the same as what over 5? 20. You see that? So 4 now becomes 20 over 5. Everyone see that? You have to write in fractions with common denominators. And so now we can finish this off. Y is all by itself and positive. 8 plus 20 is 28 over 5. That's a plus. So there we go. Now we are in y equals mx plus b form. So the intercept is 28 over 5, and you can leave it as a fraction. If you're going to graph it, you can change that to a decimal just by doing 28 divided by 5 in your calculator and put that on the graph. But you can just leave it as a fraction. It's good practice for pre-calculus work. And of course, there's your slope. Okay, questions on that? I'm going through this real quick because it should be a review. So yeah, you guys are looking like this is making sense. Any questions at all? Okay, and then we have one more little thing I want to go over then, and that is general form. Okay, so general form, it looks like this. All of the terms for the equation are on the same side, and the couple things. All the coefficients have to be either whole numbers or integers. B and C can be integers. That means positive or negative. They cannot be fractions or decimals though. A has to be positive. It has to be a whole number. Okay, so 0, 1, 2, 3, 4, and so on. So this one right here, that's acceptable general form for the equation. Now to find y-intercepts, to determine the intercepts, for y-intercept you let x equal 0. It's always let the other variable equal 0 and then solve. So here's what they did for the y-intercept over here for this example. They let x equal 0, which effectively takes this to 0. That's gone. And then we have 4y plus 12 equals 0. Subtract 12 from both sides. 4y equals negative 12 divided by 4. Y equals negative 3. Okay, so that means x is 0, y is negative 3. That's your y-intercept. And here it is right here. For the x-intercept, okay, we'll simply let x equal 0. Y equals 0 for the x-intercept, and then we have 3x plus 12 equals 0. Subtract 12 from both sides, divide by 3 both sides, and we get negative 4. So the x-intercept is negative 4, 0, and that's this point right here. You calculate those two, draw a line connecting those 2 points, and here's your line. Okay. So general form, it's really easy to find the intercepts from general form, and yeah. Okay. So, any questions? All right, so one other thing that's not in your textbook, but I'll let you know, from general form, it's pretty easy to determine what the intercepts are. Okay, so let's say we're going to do x-intercept, right? That means we let y equals 0, so this term is gone. So that's ax plus c equals 0. If we solve for x now, right, we have x equals negative c over a. So your x-intercept is negative c over a, negative this value divided by this value. You might want to write that down. Your x-intercept is negative c over a. What about your y-intercept? Well, by the same logic, we'll do this. Okay, so for the y-intercept, we'll let x equal 0, so that's gone. We have by equals negative c, so y is negative c over b. Okay, so that is your y-intercept. So those are pretty handy as well. How can you remember that? X-intercept is always negative c, right? Negative this value for both of them, and then divided by the number that's attached to the x, if you want to find the x-intercept, negative c over a. Let's just double check and see if this works over here. So for this one here, the x-intercept would be negative 12 over 3. Is that right? Negative 12 over 3 would be negative 4. Line for x-intercept is over here, yeah. Negative 12 over 3 is negative 4. There we go. Okay, negative 12 over 3. And so, obviously, it works for the y-intercept too. Negative c over b. Negative 12 over 4 is negative 3. All right? So this, of course, is in your textbook. And it's right here in your textbook on page 387. 386 also covers some, I'll let you read this too, big ideas and applying the big ideas. Do any of you have any questions? Okay, so that's a review for Chapter 10. You can complete your review assignment.